Hello, this is a little video explaining the calculations for the gas law experiment. Okay, so I made up some numbers here. These are, roughly what you might have had, but certainly there shouldn't be anybody's numbers. So the temperature I said of my solution, this temperature right here is going to be, the temperature that you measured of the solution in the small jar. The volume of water that you measured that came out, that was pushed out, that you measured in the big graduated cylinder, I made up as 324 milliliters. The atmospheric pressure, you measured that, you read the barometer, and I said, well, okay, let's say it's 30.08 inches of mercury. Your unknown carbonate that you weighed out, I said, about 1.248 grams, and you measured the volume and mass of the hydrochloric acid solution. 25.983 grams is the mass that I made up, and 25.37 milliliters is the volume. So if you're wondering where numbers are coming from, refer back to this part, because this is probably where they came from. All right, so the first thing we're going to have to do here is to calculate the partial pressure, the vapor pressure of water at the temperature of the solution. So again, my temperature was 27.4 that I made up. So what I did is I looked in that table of vapor pressures as a function of temperature that I gave you in the write-up. And I looked up the vapor pressure of water at 27 degrees, and it was 26.74 torr. And I looked it up for 28 degrees, and it was 28.35 torr. So because it was 27.4 degrees Celsius, this was closer to 27 than it was to 28 a little bit. So 1 minus 0.4 is 0.6. That's where this 0.6 came from right here. Times the vapor pressure of water at 27, and then 0.4 times the vapor pressure at 28. So if you had, say, 27.2, it would be 0.8 here and 0.2 here. If you had 27.8, it would be 0.2 here and 0.8 here. Okay. So anyway, so now we have the vapor pressure of water at our temperature. Next, we're going to find the partial pressure of carbon dioxide above the solution. The first thing I did is I took that you will do also is took the atmospheric pressure. This is the atmospheric pressure that you measured on the barometer, converted it to millimeters of mercury. There's 2.54 centimeters in an inch, and there's 10 millimeters in a centimeter. So 25.4 millimeters per inch gives us 764.03 millimeters of mercury, which is the same as torr. All right. So then that is the atmospheric pressure right here. So to find the partial pressure of carbon dioxide, we use Dalton's law of partial pressures and subtract out the vapor pressure of water from the total pressure. Okay, remember we just calculated this on the previous screen. This is up here. Do the subtraction. This is the the partial pressure of carbon dioxide above the solution with the numbers that I made up. And then we're going to need, in just a moment, to have that in kilopascals. So I'm going to convert that right here. I took the partial pressure of CO2 in torr times 101.325 kilopascals per 760 torr. This 760 is exact. So I got 98.21 kilopascals. Next, I'm going to find how many moles of carbon dioxide would have been in the solution. This is the equation that I gave you guys. In here, it had T. This is the temperature. My temperature that I made up was 27.4, so I took negative 1.043 times 10 to the minus 7th times 27.4 cubed, and then 27.4 squared, 27.4. And this right here is what we calculated just on the previous screen. This is the partial pressure of carbon dioxide above our solution in kilopascals, and then you divide by 5,000. So take that as an exact number. And I got this number right here, 0.000572. That is the mole fraction of carbon dioxide in my solution of the numbers that I made up. Okay. Now, mole fraction, that's just the moles of the component divided by the total moles in solution. So moles of carbon dioxide divided by the moles of water plus the moles of HCl. And so just rearranging this a little bit, solving for moles of carbon dioxide in solution, just cross multiply. It's this number times the total moles of water plus hydrochloric acid. All right. So that means we need the moles of hydrochloric acid and we need the moles of water. So to get the moles of hydrochloric acid, that's easy. We measure the volume with the burette, convert it to liters by moving the decimal 3 to the left. So I made up 25.37 milliliters, so 0.02537 liters, times the molarity. I believe this is the molarity of your HCl, but check it to make sure. Moles per liter gives me moles of hydrochloric acid, HCl in there. Next, to get the moles of water, okay, I'm going to take the moles of HCl and convert it to grams by multiplying by the molar mass of hydrochloric acid. That's what this is right here. And for my numbers, I got this many grams of hydrochloric acid, about 2.968 grams. The total solution weighed 25.983. Again, look back to that first slide. This, I made this number up, right? Subtract out the mass of hydrochloric from the mass of the solution. That gives me the mass of water, right? Then go from grams to moles by dividing by the molar mass of water. And I got this many moles of water. So now I know moles of hydrochloric acid, moles of water. I can plug into that equation I got and get moles of carbon dioxide. So the moles of carbon dioxide in solution will be what I showed you before, this number times the total moles of water plus HCl. Plug in the numbers in we got for water, HCl. I get this. So that many moles of carbon dioxide would have stayed dissolved in solution, not gone off as a gas. Oops, what did I do here? Skip the slide. All right, now we're going to find how many moles of carbon dioxide ended up in the gas phase with my numbers. This is just the ideal gas law. So we calculated earlier the partial pressure of carbon dioxide by subtracting the partial pressure of water from the atmospheric pressure. And we got this already, right? So we got this on a previous slide, that number right there. The volume was 324 milliliters, 0.324 liters. This is R in units of liters, torr per Kelvin mole, because I didn't want to convert Kelvin to atmospheres. Doesn't matter, same thing. And this is our temperature, 27.4 degrees Celsius converted to Kelvin. Plug these numbers in, and I get this many moles of carbon dioxide that were above the solution in the gas phase. Now the total moles of carbon dioxide is just the moles of carbon dioxide that stayed dissolved in solution, plus the moles of carbon dioxide that were in the gas phase above the solution. We got those numbers. Actually, this is above solution right here. This is that stayed in solution right here. When we add them up, I get this many moles of carbon dioxide total that were given off in this reaction with my numbers that I made up. Finally, to calculate the molar mass of the unknown, just take the mass of the unknown. Again, I made this number up, but so you weighed out the unknown. You have this number for yourself. Divide what we just got, the moles of carbon dioxide, which is equal to the moles of unknown. Remember, it's a 1-to-1 mole ratio, so we got this many moles of CO2, which is equal to the moles of unknown. Do the division, and that's our answer.